I'll quickly summarize FeNa, urine sodium, and urine osms for the different forms of acute kidney injury. And I'll take it by sort of test. So FeNa, it's telling you how much is the body trying to reabsorb sodium. We expect that to be low in pre-renal states, typically less than 1%. We expect it to be high, greater than 2% in intrinsic renal disease, and it sort of varies with post-renal. The question that we had today had it right at 1, which sort of falls in that gray zone. And that's why you look at each of the columns and you don't hang your hat on any one in particular. So that's the FeNa. Now we talked about the urine osmolality, right? So in the question that we discussed, we expect that the kidneys are unable to reabsorb both electrolytes as well as water. So we expect the water to stay in the nephron, to stay in the tubules, diluting and leading to a relatively low urine osmolality. Remember that urine osmolality covers a broad range. In a healthy kidney, you can concentrate all the way up to 1200, you can dilute all the way down to 50. So you expect it to be relatively low in post-renal states, and the opposite is true in pre-renal. Why? Because the body's thinking it doesn't have enough volume. So it's trying to pull, concentrating what's left in the tubules, right? The last point I'll make is about the urine sodium. The urine sodium really isn't a test that's used for acute kidney injury as much. It's more commonly comes up in questions of hyponatremia. But in this case, in a post-renal situation, you expect that the kidneys are not able to do their job, and that job is to reabsorb electrolytes. So the urine sodium is relatively high in the vignette that I gave. Okay, and again, the answer choice was A, highlighted those 3 points.